Okay, let's go ahead and get started. What this video does is cover Module 1 of your Cisco curriculum entitled Networking Today. We start off with section 101, says why should I take this module? Basically, this module is an introduction. It may be some review from 105 or 111, but it talks about networking devices, types of networks, that type of thing. What we're going to cover in this module is outlined here in section 102. We're going to talk about how we use networks in our life. We'll talk about the different types of components that we might have in devices, switches, routers, that type of thing. We will talk about how we represent networks and talk about them, and topologies, which is the layout of the network. We'll talk about different types of networks. We'll talk about internet connections, both locally and to an internet service provider. We'll talk about what it means to say that we have a reliable network. There's 4 basic requirements for that. We'll talk about network trends, which will be things like bring your own device, online collaboration, etc. We will also talk briefly about network security. We will revisit security throughout the course. And then we'll finish this up with something called the IT professional, which is basically talking about jobs in networking. So if we move on to the next section about how networks affect our lives, we probably know this. We are very connected these days. Most of us are going to have internet connections at home. We use PCs or laptops in the classroom, either directly wired into the network or through a wireless access point. A lot of times when we go to restaurants, we have wireless access points. We're going to have a lot of things in our home connected to the network, TVs, refrigerators, streaming devices, that type of thing. Section 112 is a brief video. It's about 2.5 minutes. It talks about the Cisco Networking Academy. So I am going to play that and record this in this recording. Hopefully the sound comes through okay, but if for some reason there is no sound, you can of course log into netacad.com, go to module 1.1.2 and play it for yourself.
This is the world, always moving, always changing, and nowhere is that more true than in technology. From the very start, we've been on a quest to make things easier, move faster, and expand our opportunities. And with each new innovation, the pace of change has only accelerated. To keep up, education has to advance and evolve as well. At Cisco Networking Academy, we believe that powerful learning comes from hands-on instruction with real equipment and software. So we're committed to giving our students a real-world grounding in today's most valuable skills. We've developed many of our own tools, including simulators that help them test their ideas at scale in different environments. And we keep it real by giving students the chance to test their skills in competitions and hackathons. They receive personalized feedback every step of the way, and not just from instructors. Automated, performance-based feedback is an integral part of the learning experience. Our classes are translated in up to 20 languages, making it easier to learn in your own language and share experiences with others around the world. More than technical skills, it's a broad-based program focused on creating global problem solvers, ready to move the world forward. Our students become T-shaped professionals, meaning they get deep technical knowledge in at least 1 or 2 high-demand job areas. But they also get the broader range of skills needed to collaborate across related technologies, which makes them even more valuable to potential employers. Preparing students to become the innovators of tomorrow, capable of successfully contributing to multidisciplinary teams that are setting the pace for the future of networking, the Internet of Things, security, programming, and information technology. They learn from the best trained instructors and earn certifications that can get them better jobs, higher pay, and a well-rounded career, meeting today's needs and tomorrow's opportunities. There's no saying where technology will take us next, only that the ones leading the way will have the T-shaped skills you get at Cisco Networking Academy. It's how academies, educators, and students keep ahead of an ever-evolving world. Discover the latest courses and set out on an exciting career journey at netacad.com.
Okay, so that was a little bit about netacad.com. 113 is entitled No Boundaries. This is kind of a slogan or saying that Cisco has been using for a long time. There used to be boundaries, to go to other countries, you'd have to get a visa, you'd have to travel. If you wanted to go to California, it would take days and days and days to get there. If you wanted to talk to somebody and you sent a letter, especially if it was in the Pony Express days, it would take days for the communications to get there. And their point is that networks kind of eliminate those boundaries. You can talk to people all over the world. You can send them email that will show up in a few seconds. You can have interactive chats with them. You can call them with a voice over IP phone or call them on something like Skype and talk to them. So a lot of these boundaries, whether it be physical boundaries or kind of time limitations with networking, have gone away. In the next section, we're going to talk about network components. These are the things that you may have that either make up the network or devices or services that you might have on the network. And first, they start out talking about host roles. So typically when you say host, you mean a PC or a server. And that's one of the first things they're going to talk about down here is they have a picture and they're talking about client-server communications. Now, you should have been introduced to this in 111. But basically, the way I like to define the server is it is the thing that has the resources. So if you're talking about a web server, the resources are web pages, and that's where the web pages are either stored or generated. In this case, the client is something that asks questions of the server. So the client piece of software would be a web browser, and it would be sending URLs to the server, asking for it to locate web pages and send the information back to it. Here's some examples. I used web server. That's an example that most people are familiar with. Same thing for email servers. An email server is an email server because it has the email messages. Your client is either a web browser, connected to Gmail, for example, or a piece of software such as Apple Mail or Outlook that is asking the server, show me this email message, show me my new messages, delete this message, store this message away in a folder for me. And then finally they talk about file servers. So in the case of a file server, there are a collection of files that you want to share out. And then in this case, the client is usually the operating system. You mount the drive or mount a volume, and then you're able to look at the files. You might FTP into it. FTP stands for File Transfer Protocol, and you may upload and download files from the file server. So there's more than one way often to access the servers. Kind of a contrast to client-server computing is peer-to-peer computing. A lot of times when you hear peer-to-peer, you think of sharing music or something like that. But basically, a peer-to-peer relationship means that two computers are peers to each other, which means they have basically the same capability and power. That doesn't mean they have to be the exact same machine. It doesn't mean they have to have the exact same software installed. But they kind of do the same type of thing or are capable of doing the same thing. Some of the advantages to peer-to-peer networking is it's easy to set up. A lot of times it is as simple as just plugging your computer into the network. Or you might need to download a piece of software to file share, for example. It's less complex. You don't have to maintain, an OS, a server OS that has something like SQL on it that's going to be complex in itself to set up so that you have a database server. Typically, you don't have those type of issues in peer-to-peer computing. It's lower cost because you don't need dedicated hardware. You don't need high-powered network. Just typical PCs. And they're fine for simple things like transferring files and sharing printers. Some of the disadvantages, however, are there is no centralized administration. So you don't have a knowledgeable IT person that is maintaining and setting up this environment for you. They may not be as secure, again, partially because you don't have an IT professional watching over the machines and protecting them. Since these are typically consumer grade PCs, they're not as scalable as you might have in the case of a server. And in peer-to-peer, often if you're sharing files back and forth, for example, each device works as a server and as a client concurrently, so that may impact performance. 123 talks about end devices. So an end device is typically a device that a user is going to use. On the local area network, the LAN on the left, they show some desktop machines, they show a laptop, they show a voice over IP phone. These are things that users are going to use. A lot of times end devices and user devices are used interchangeably with each other. Over on the right, it looks like we have three more PCs. So the end devices are things that an end user uses. We send packets through the network, so these devices communicate with each other. So I'm going to play this animation. And originating from this PC is a packet. It's going to go over an internetwork or possibly the internet. That device is a router. In this case, there's 3 different ways that this message could go. So the router is going to decide the best thing to do is send it to that router. From there it goes to the switch, which makes it to its final destination. So that's how the Networking Academy shows the flow of network packets. They show them as little envelopes that have information inside them that are going to traverse across the network from a source, in the case this PC, to a destination, in this case the PC over here. When we were going through this center section, we were going through something called intermediary devices. These are things that exist. Network packets travel through them. They have to exist and be configured correctly for the network to work, but these are not things that the end users set at and use. So these are the standard Cisco icons. You will need to start learning these. You'll be introduced to more of these as we go through the curriculum, but these are kind of the basic ones. We have a router, we have a switch. Anytime you put antennas on something, so we have a router with antennas, so that's a wireless router, like a wireless access point. This is a multi-layered switch, which we'll talk about later. And then anything that has bricks on it has a firewall. So this is a firewall appliance. And again, a firewall is something that decides whether or not packets should be able to pass through or not. So it's kind of a security thing. Down here it talks about some things that intermediary devices do. They regenerate and retransmit signals so that they can travel further distance. They maintain routes, or what they're calling pathways here, to determine how the packets should flow. So for that example, the router on the left had 3 directions it could send the packet, and for some reason it decided that sending it straight across was the best thing it does. It can identify and deal with failures or different types of failures that we might have. It can give messages priorities and handle packets based on those priorities. And then it can permit or deny the flow of data based on settings. That would be your firewall. Now, one thing that I'm going to do after I finish this lecture is I'm going to create a supplementary lecture on network devices that will talk about repeaters, hubs, bridges, and switches. Some of the devices, some of those are obsolete, but it helps to talk about them so that we understand how the current devices function. So there will be a supplementary lecture on networking devices in the very near future. Another thing that we have to talk about in this class is network media. And basically, media is how those packets flow from one location to another. Very common is the first one, wires, metal wires, copper wire. Here we have some twisted pair cable. Here we see the bare wires. Here we have RJ45 jacks on them so they can plug into equipment. That is going to be the primary type of media that we talk about in this class. However, we also do have fiber optic cable, which is glass or plastic that uses lights either from a light emitting diode, an LED, or may actually use a laser to send light pulses along the strands of glass to represent the data we're sending. So here's some some bare fiber optic cable. Here it is terminated with different types of connectors that we might have on fiber. And then I don't have a lot of complaints about the NetAcad curriculum, but I always hate that they call wireless the medium. Wireless is something that functions over air or free space. So the media is really the air and the free space around us that we send signals wirelessly to an access device, or an access point, or a camera that has a wireless antenna, etc. When you choose media, there are several things that you need to think about. What is the maximum distance that medium can successfully carry a signal? For example, in the case of copper cable, we have a 100-meter limit before the signal possibly degrades so much that it will not function correctly. In the case of fiber optic cable, we have some that'll go like 1.5 kilometers. So what type of media you use dictates how far the signal will travel. Another thing is what type of environment will the media be installed in. For example, if you're in a factory that has noisy electrical equipment and motors, copper is going to be real susceptible to picking up stray signals and possibly corrupting the data. Another thing, for example, fiber optic cable is fairly fragile. So if you're going to be in an environment where the cabling is being moved a lot, fiber optic cable might not be a good choice. The other is how fast can you send data. If you're need data sent very quickly, or you have very large files that you need transmitted in a reasonable amount of time, that will factor into the media and the devices that you use. And finally, what is the cost of the media and the installation? Copper cable is one of the cheapest. Fiber optic cable is one of the more expensive ones to purchase and to install. So as we go through the class, we'll come back and we'll visit especially this criteria here. 126 is called Check Your Understanding. We have these periodically throughout the curriculum. There are usually several per module. So basically, after you've studied and read a section, you can go through, and this is making sure that you understand the things about network components that we just talked about. So it's some questions and answers. You can go through, you can answer these, in this case, 3 questions, and then you can click check, and it will tell you which answers are correct and which are incorrect. You can reset it and try again, or you can just say show me, and it will give you the correct answer. So hopefully you do more of the studying and checking to see how you did instead of just saying show me the answers. 1.3 is talking about network representations and topologies. As far as representations, it's more breaking down the items in a network um, as to what type of device we have. So up here at the top we have end user devices. We've seen some of these before: IP phone, desktop computer, laptop, a tablet that's connected to our wireless network. We might have printers that are either connected wirelessly or hardwired into our network. And then a telepresence endpoint. So if you have teleconferencing and you have several people in a conference room here and you're talking to people at another location gathered in a conference room, you may have a device that is basically a TV and some cameras and some software that allows you to interact with each other as if you were in the same room. As far as intermediary devices, we talked about routers, LAN, wireless router, firewall, multi-layer switch. We saw all those before. And then down here at the bottom, we show the different type of media we may have. In the middle, a solid line is referred to as LAN media. That is typically Ethernet or Ethernet cables. If we're going over a wide distance, for example, from one location to another, we have what I call the lightning bolt symbol. That's wide area. Networking media, that is networking that's typically far away from each other. And then this two superimposed sine waves that are 180 degrees out of phase is how we represent wireless communications. Several things they talk about here is they're talking about drawing pictures. We'll talk about that here in a moment when we talk about physical and logical topologies. But in addition to these, several things that you need to draw in addition to the media. We have something called a network interface card, which is a physical port either on our PC or a router or a switch, any type of end device or intermediary device. So we may connect to that. Physical port is where that actually plugs in. We physically have, for example, an RJ45 jack connected to an Ethernet cable that we would plug into a physical port on a switch. And interfaces are typically used to refer to ports that are used to interconnect intermediary devices, but a lot of times people will refer to the NIC card as an interface. On your Cisco networking equipment, what I've been describing you would think of as a physical connection. You can also have virtual interfaces, which we'll talk about more when we talk about switches and routers. One thing that is handy, we're talking about pictures, is a topology diagram. There are two different types of topologies that we might talk about. We might have a physical topology or we might have a logical topology. In the case of physical topology, we're telling where things are. Maybe not exactly on a floor plan, but pretty close. For example, we have a server room. We tell its location. We have a switch. We have a router. We have another switch. We have some servers. It tells what rack they're in and what shelf on the rack, etc. So it explains physically where the devices are. Close by, presumably, there's an IT office that we run into the server room to get connections to this switch. We have a probably comm closet in 2124 that has a bunch of switches in it that then goes out to classrooms that have devices in it. And here's another example. You might show 20 devices here, but you know the assumption is probably that there's not one laptop per classroom, that there are devices, multiple devices in the classroom that connect to the corresponding switch. When we talk about logical topology, we're talking more about the networking aspects. What network is this device on? How is it interconnected to other networks? How is it connected to the internet, etc.? So you'll notice here that it says this is the 10 network, this is the 11 network, the 102, the 101, the 100 network. It may also tell what interfaces or ports it's plugged into. So G stands for gig, FA stands for fast Ethernet, for example, or just F here. And this tells exactly what port they plug into. So when we start talking about switches and routers, we'll talk more about these interfaces and their speed. So here's a check your understanding for 1.3. Again, you can go through, do that on your own. This one has 4 questions, and then you can answer and check them like you did on the other one. Okay, common types of networks. So there's probably multiple ways that we could refer to what type of network. For example, LAN or WAN, that type of thing. And this is talking more about the number of devices you have and the complexity of the networks. So down here, as we click, will show us a picture down here. So a small home network. Years ago, it used to be, do you have a computer? Do you not have a computer? Now it's typically, how many computers do you have in your house? But a small home network is confined to your house or apartment, and it'll have probably, a desktop, laptop, maybe multiples. You may have a printer or scanner connected to it. You may have security cameras connected to it. You may have DVRs connected to it. You may have TVs connected to it. The network's much larger these days, even though it's contained within your home, as more and more devices are networked enabled. Kind of the next step up is a small office or a home office, where you have a relatively small number of people, 5 or 10 people. Or in the case of your home office, you may have 1 or 2 people, but you may have voice over IP phones. You may have wireless access points. You may have more printers, that type of thing. So the configuration and maintenance of this may be a little more involved. As we move up to medium and large networks, this might be, for example, a business that has a whole building. So there's more people, and therefore you need more connections. And then finally, worldwide networks, which will be international, global type networks. And of course, the networking to do that is going to be much, much, much more complicated than in your home, for example. The other way to categorize this is they talk about LANs and WANs. A LAN is a local area network. It is things that are close proximity to each other. In a school environment, maybe each building is its own LAN, maybe each floor within the buildings is its own LAN, but it is a collection of closely proximity machines, like I said, and typically same type of function. Like this is the engineering department, they're on a LAN. This is the accounting department, they're on their own LAN. And then a wide area network is things that typically interconnect LANs. Typically geographically spread out from each other is another way to do that. Okay, so this is just showing you some information so you can read through that. They have some kind of general information about these. Again, they're limited to each other. LANs typically have relatively high-speed bandwidth internally. Wide area networks, typically the WAN links are slower speed than you might have on your local area network. And then finally down here, 143, they're talking about the internet. Now, one thing I harp on, and I always tell my students, if I say I harp on something, that you can kind of mentally think, gee, I bet that's going to be a question on an exam. So I can pretty much guarantee you what I'm going to talk about now will be on your midterm exam. And that is internet with a lowercase I and internet with a capital I. Internet with a lowercase I is defined as two or more devices connected together using TCP/IP networking. So technically, you can take a crossover cable, connect two PCs together, and you have an internet. That internet are those two machines. They can communicate with each other over the crossover cable. Internet with a capital I is the worldwide network of networks based on TCP/IP. So that is, the global network, the internet, capital I. Also, another thing I like to do is to, clarify things that are either just incorrect or may make you appear not to be as knowledgeable as maybe you are, and that is if you use the term internet and the web interchangeably. The web is one of many, many, many services that runs over the internet, capital I. So the web and internet cannot be used interchangeably and be accurate. Another thing, not as big a distinction these days, I would say, as maybe in the past, is intranet and extranet. An intranet is a network where access is restricted internally to your company only, as shown in the diagram. And the internet is the worldwide network. And your extranet is something that sits in between. You expose enough that your suppliers, your customers, or collaborators can access your information on the extranet, but they should not be able to get into your intranet. It should be protected to, again, company only. Here's another check your understanding. You can do that on your own. And we'll move on to internet connections. So, talking about internet access technologies, primarily this is talking about your ISP, your internet service provider. This is how you get your connection to the network. Everybody has an ISP. It's pretty obvious that you probably have Windstream or Insight or Metronet, somebody like that provides your internet service at home. But, University of Kentucky has an ISP. We actually have a number of them. KCTCS has an ISP. Last time I checked, it was Cincinnati Bell. So regardless of how big or how small it is, if you want access to the internet, you need to have an ISP. What ISP you choose is based upon what type of service is provided. Some places you have choices. Other places you may only have one choice if you want to get on the internet. So it kind of depends on how big a city you're in and how many companies are functioning as ISPs there. In a home or a small office, these are the types of things you may have. Years ago, a lot of people had dial-up. That was the only type of internet you could get. These days, if you want to get your internet service from your phone company, you would use DSL, which stands for Digital Subscriber Line. If you want to get it from your cable company, then you would, get a cable modem and have broadband over cable. You can get cellular connections, so you would use your data plan with your cell provider to get a connection to the internet. You can have different types of satellite communications that allow you to communicate with the satellite in space. That used to be limited to downloading coming from the satellite, uploading going over your dial-up telephone. But these days, satellite providers are able to be your uplink and downlink. So you can read through that on your own. If you are a business, you may use some of those options, but you may have dedicated lease lines that you rent from the phone company. You may have business quality DSL. You may have Metro Ethernet, that is available through a metropolitan area, and you may have satellite internet that you use to communicate with your ISP. There are some places they don't have cable on here, but cable is very fast, typically faster than DSL. I'm sure there's some people that, get cable TV at their business and then use cable as their internet provider. .154 is talking about the converging network or a converged network. At the top, they're saying this is traditionally what we used to do. We used to have a computer network that all of our computers were on. We had a telephone network that only had our telephones on it. And then we had broadcast TV or cable companies that did our video. These days, with a converged network, basically what they're saying is you have a network, and regardless of what you need to do, use that network. So at home, you can get a connection that provides you with internet, provides you with your cable TV, and provides you with a voice over IP phone. And you can do the same type of thing in your company as well. So a converged network means there are many types of communications that are happening over a single network. 155 is talking about Packet Tracer. Packet Tracer is a really awesome program. Years ago, if you wanted a network simulator like this, it cost you like $1,000. A long time ago, Cisco bought one of the better third-party network simulators and turned it into Packet Tracer, and they continued to improve it over time. I watched the intro to Packet Tracer video, or actually a course that Netacad has, and it was amazing at how much stuff had been added to Packet Tracer since I was a student and since the last time I really looked at all the functionality of it. So what this video does is it has you download and install Packet Tracer, and I will actually have an assignment that tells you how to get Packet Tracer as well and has you start it up. You will be using Packet Tracer a lot in class. It helps you practice what you're learning in class. It helps you sharpen your skills. It allows you to simulate networks and learn about things like the Internet of Things that you may not have actual physical devices for, but you can simulate them. And it helps you prepare for a certification exam. And actually, on a certification exams, you have these activities that are basically many Packet Tracer exercises that you have to do to complete your certification exam. And I mentioned it briefly. There is an Intro to Packet Tracer class that you can go to the main netacad.com and sign up. It takes about 10 or 11 hours to watch it. I think that's what they said, but just the first hour or so will probably teach you everything you need to know to use Packet Tracer in 161. I'm not going to play this video. It is 3 minutes and 33 seconds, but you can watch that on your own. And again, I'll be providing you the same information via a homework assignment. 156 is also a video talking about getting started in Packet Tracer. I highly recommend that you watch this. It is 7 minutes and 44 seconds, but it will hopefully get you comfortable with Packet Tracer so that when you have your first Packet Tracer activity, which is coming up here in a minute or so, that you feel comfortable in using it. So 157 is a Packet Tracer activity on network representation. This will be appearing in Blackboard. There are something called challenge questions at the end of this Packet Tracer. You do not have to answer the challenge questions, but you do need to answer all the others. What happens here is this is the Adobe PDF icon. So if you click on that, what it's going to do is it's going to open up the assignment for this lab. Like I said, here's some questions. You do not have to do the challenge question. And then you will be turning that in, and when you do that, what I expect is a single PDF document to be submitted to Blackboard. So there are several ways you can do this. You could say open this in a new window, print this, write your answers on here, and then scan it to a PDF, and then send that PDF in. There are ways that you could actually open this PDF and type into it if you have Adobe Acrobat or some type of PDF editor. You could edit your answers into this and then save that and upload that to Blackboard. So there's many ways to do that. You just need to find out what works best for you. The other thing you have is you actually have, this is the download button. You have what's called a .pka file. This is a file that Packet Tracer is able to open. So you would need to download that to your computer, open it up with Packet Tracer, and then do all the things that are in the lab document, or I'm sorry, the Packet Tracer. So I would refer to this as Packet Tracer 157 or PKA 1.5.7. So like I said, watch for that to be appearing in Blackboard. Okay, 1.6 is talking about reliable networks. When we talk about network architecture, we need to take these things in mind. We'll talk about these in more detail, but the 4 things that you need to have is fault tolerance, scalability, quality of service, and security for your network to be considered a reliable network. So fault tolerance, the best definition I can think of fault tolerance is designing things, in this case a network, so that it is able to function in adverse conditions. The easiest way to explain it is like servers have dual power supplies. If one power supply fails, there's a second one to keep the server up and running, hopefully until you can replace the failed power supply. Here they're showing redundant connections. So instead of having one router or 2 routers between the internet and the networks shown here, they actually have 4 routers, and they put connections crisscross between them. So if this router here goes out, traffic that would normally flow through that router is able to hop over to this router and go out to the internet. So a lot of times fault tolerance is created by having redundancy. In this case, redundant routers and redundant paths. In the example I gave before, having redundant power supply. The next thing is scalability. That is the capability to add machines. So usually when you spec out routers and switches, you think about how much you may grow in the future, and then you spec out the machines with a little expansion room so that you don't have to come out, if you don't, you might be able to spend a few extra $1,000s and be able to make your environment scalable. If you buy exactly what you need, maybe it costs you $10,000, and then when you need to expand, maybe you have to spend another $10,000 because you didn't think about scalability when you were designing your network. So you want to have room for growth, basically. The next thing is quality of service. Quality of service kind of deals with the fact that some packets are more important than others. Stereotypical example is streaming video or voice over IP. If you're watching a movie and it pauses, you lose packets. There's really no way to recover from that. If you're talking to somebody on the cell phone and the conversation sounds like, hey, what? Night. because you're losing packets. There's no real way to recover from that other than going, hey, what did you say? You're breaking up. Could you say that again? Still can't hear you. Can you say it again? So you want to give priority to streaming video, streaming audio, are, like I said, the two primary examples. Other things like reading a web page or reading email is not as important. If you pull up a web page and it comes up in 1 second as opposed to a half second, you're probably not even going to notice that, but that's an acceptable thing. If it takes, 15 seconds to download all of your email messages as compared to maybe 5 seconds, again, most people are not going to be bent out of shape about that. So that's what quality of service is. And then finally, network security. You don't want somebody hacking into your accounts. You don't want people stealing information, ordering items with another person's credit card, seeing their confidential medical correspondence or maybe correspondence with a significant other, that type of thing. So you want to protect that. You also want to protect your equipment. So, for example, if somebody hacked into this router, they could delete the configuration, and then a big chunk of your network, like almost half of it, is no longer functioning because it can't communicate through this router out to the internet or to other devices on your network. Down at the bottom, there's something that's referred to as the CIA of security, and basically that's confidentiality, integrity, and availability. Confidentiality, as the name implies, is basically making sure people can only access the information they need to, and that they can't read other people's data that they should not be able to. Integrity means that the data is valid, that it has not been tampered with or altered in any way. And then availability is, you want things available all the time. You want Amazon to be up all the time. You want your email to be up all the time. You want your TV, your cable TV, your satellite TV to be working correctly all the time. So that's ensuring availability. 166 is check your understanding on reliable networks, so you can do that on your own. The next section, 1.7, is talking about network trends. 171 is recent trends. These are kind of hot topics these days. Bring your own device, online collaboration, video communications, cloud computing. We'll talk about those in the following 4 or 5 sections in this curriculum. So bring your own device is basically bringing your own device to work or school. A lot of people at school, you have a desktop in the classroom, but you want to bring your laptop because you're more familiar with it and it has all the information you may need on it. You may do the same thing at a job. You may be supplied a computer at work, but you may bring your personal device in with you. Some places don't allow that. Some places say, no, you use our devices. You're not allowed to bring an external device and place it on our network. Some places are kind of the other extreme. It's like, oh, you want a job here as a graphic designer? Okay, that's great. We're going to offer you a salary. We're going to offer you a job, but you have to bring your own Mac to do your work on. We're not going to provide you with a machine. So those are some examples about bring your own device. Usually the big concern about bring your own device is security. You want to make sure that by bringing this device or somebody getting this device, bringing it onto your campus or your place of employment doesn't compromise security of the network. Online collaboration. The next one is video communications. These are kind of closely related. If it was me, I would have done video communications first because online collaboration is that plus a lot more. So you can get online, you can have classes, you can hold lectures, You can put up a shared whiteboard where everybody on the call can draw pictures. You can contribute documents that are shared. Those are all examples of online collaboration. And they talk about WebEx here as being a collaboration tool that lets you do a lot of these things. That's because WebEx is made by Cisco. As far as video communications, Skyping with somebody, doing FaceTime on your iPhone or Apple device are all ways to do video communications. There are actually video phones, usually voice over IP phones, that you can see the person on the other end while you're talking to them. This video is 1 minute and 21 seconds. It's called Cisco WebEx for Huddles. I will attempt to play that video here. It's 1 minute and 21 seconds. Like I said, if for some reason it does not play correctly, you can come back into the curriculum and watch it.
Hello? Hello? You're gonna have to call me back.
Did you guys book this room? Because I'm pretty sure I booked this room.
Okay, another hot topic these days is cloud computing. Basically, this is somebody like Microsoft, Amazon, Google, IBM having a wide collection of resources in multiple data centers, highly redundant, highly available for you to use, as opposed to buying your own physical hardware. We are in the process at UK of moving a lot of things to the cloud. We use Azure by Microsoft for a lot of that, but we also do have things in Amazon AWS and Google GCP, which is stands for Google Cloud Platform. So as appropriate, we're moving things. There are some things you don't want to move to the cloud or inappropriate to move to the cloud. But there are a lot of things that are kind of general purpose computing that are really good. The ones I just mentioned are primarily public clouds. That is, you pay as you go for what you use, and there are other people sharing the resources. A private cloud is a cloud that is intended for a particular organization. Private cloud, you can actually go with one of the public cloud providers and pay for a private cloud. Or a lot of times you can buy kind of a cloud environment, purchase it and put it in your organization and refer to that as a private cloud. A hybrid cloud is when you use public cloud along with a physical data center or private cloud and kind of share services between those. And then finally, they have community clouds that are exclusive to specific entities. I know that AWS and Azure both have, what I would consider government clouds. The only customers that are allowed to use those are government entities. The next one talks about technology trends in your home. It's just amazing all the things you can do these days. Your car can have an internet connection, you have your cell phones, you have your computers, you have your laptops, you have your TVs, you have your refrigerators. You may have a Ring doorbell where you can see who's at your front door, or it may alert you when somebody walks up on your porch. DVRs, webcams, and on and on and on. Lots of devices within your home that are now internet capable. And you can control them remotely. I can be at my office and look and see what the temperature is in my house and adjust the thermostat, that type of thing, remotely. Power line networking, there are actually two different types that I want to discuss. The first one I don't think they really talk about here, but the power lines you have outside your house are capable of communicating over Ethernet on those. For example, my meter base on the power meter on my house is remotely accessed every month to retrieve my usage and then generate my bill. They do come out once a year to double check and make sure that the numbers they're getting match up with the numbers on there, but that is all done remotely over a network running over the power lines. Now then, the type they talk about here is using the power lines within your house. So wherever your internet connection comes in, you buy an adapter, you plug it into the wall, you take the connection from your ISP, from your cable modem, DSL modem, whatever, plug it into this device. Then you go other places and plug them in, hook this computer up upstairs, hook this computer over in the living room, it looks like, that type of thing. And then take an RJ45 cable from this device and plug it into the TV or your computer, whatever device you're wanting to connect to the network. And then what it does is it sends signals over the power line in your house that allow these little adapters to communicate with each other. There are lots of reasons for doing that. If you're in an apartment and you don't have Ethernet run and you're not allowed to cut holes in and install Ethernet connections, might be one reason. In your home, maybe you don't want to cut holes in your house, or it's too difficult to run from where your internet comes into the house, up 2 floors to a bedroom, something like that. It's a lot easier to plug these in. And then I also know somebody who used this in their parents' house because his father had a pacemaker. And it was an older pacemaker, and things like microwaves or cell phones or Wi-Fi could interfere with the operation of the pacemaker. So he actually bought these so that his dad didn't have any issues. So that's power line networking. Next, we have wireless broadband. There are ISPs that provide you with service wirelessly, much like TV broadcast, where you have a receiver that reads the communications from the ISP and gives you your connection to the internet. 1710 is one of the check your understanding activities that you can do on your own. 1.8 is talking about network security. This is a super fast introduction. We will be talking about security as it relates to networks and networking devices throughout the curriculum. But here they're just talking about security threats. Again, this should be review from 111. But viruses, worms, Trojan horses, spyware, adware, these are all pieces of malware, which is a shortening of the term malicious software, that can run random code on your device and possibly compromise information on the device. Spyware watches what you do and tries to intercept things like passwords, credit card numbers, that type of thing. A 0-day attack is what it's referred to the first day an attack comes out. What happens is if it's a large vulnerability, it's going to take the virus protection people a while to identify the malware, figure out how to identify whether a machine's infected or not, and then figure out how to remove the software. Then they have to update their software to do all those things, and then you have to have it distributed. So there's a period of time where even if you have good virus protection, you may still be vulnerable to attack because it is so new. Threat actor is the person doing the malicious attack. Denial of service attacks are attacks where you try to inundate a machine or a server with lots of traffic or invalid traffic so that it will not function correctly for legitimate users. Data inception and theft is basically trying to steal personal, private, confidential data off of a organization's network or from their database servers. And then identity theft is the process of trying to gather enough information so that you can impersonate the person, a lot of times so you can get a credit card in their name, that type of thing, in the context of computers so that you can impersonate them and authenticate or log into a computer or network. As far as security solutions, things we can do to prevent those is, can't remember if it was Cisco or somebody else used to refer to software as anti-X software. So if you're trying to prevent viruses, you would use antivirus. Virus would be the X. If you had spyware and you were trying to eliminate that or prevent that, then you would use anti-spyware, etc. Another thing we can do, I kind of skipped over this graphic here, but they're showing a firewall. As traffic comes in from the outside, the firewall makes decisions as to what to pass into the network. Even with a firewall, you can still exploit vulnerabilities and be attacked. And there is also a possibility that you have a person within your organization that is being malicious, either because they are pissed off at you or because they're trying to steal money, that type of thing. So by firewall filtering, you're trying to prevent unauthorized access to your network. In regards to firewalls, sometimes the firewall is a piece of software. PCs, Macs, desktop machines have something called a software firewall that you kind of envision a firewall setting at your NIC, either where your network plugs in or at the antennas on your wireless access point that are watching packets. But you can actually have physical firewall systems that set on your network and try to protect it. They use access control lists that tells who can do what. They can base it upon the application they're using or the IP addresses they're going to or coming from. There's intrusion detection systems, IDS, which they don't have listed here, and IPSs. We'll talk about IDSs first, intrusion detection system. They watch the flow of traffic on your network, try to determine whether you have a virus or if somebody's hacking, and then after they've detected that, they notify you. They send an email. They turn an icon red, in your machine room or something like that and says, hey, I think this bad thing's going on. An intrusion protection system, which is listed here in the book, does the exact same thing. But the difference is once it detects a problem, it immediately corrects it. So you hope that you don't have a lot of false positives and knock somebody off the network inadvertently, but most IPSs are pretty good and do a good job of protecting your network. VPN, virtual private networks, again, this should have been something you talked about in 111. It's basically providing a secure connection over a public infrastructure So I always joke about the hackers that are at Chick-fil-A in the morning. So if you're at Chick-fil-A in the morning trying to read your corporate email, and you don't use a VPN, a hacker sitting there in the restaurant with you might be able to see your email messages or the data communications that you're having. If you have a VPN, you basically have a secure tunnel from your laptop to a device called a VPN concentrator at your place of business. And between your laptop and your place of business, everything's going to be encrypted. User ID, password, all traffic. And if you do have a hacker sitting there trying to sniff your packets, watch what data you're sending, it's just going to look like random garbage to them. So VPN, again, a way to have a secure connection over an insecure or public infrastructure. So check your understanding over network security. You can do that on your own. And we'll move on to 1.9, which is the IT professional. 191 talks about the CCNA. I am going to make a video here in a bit, or maybe actually I've already made it and posted it, that talks about what the CCNA is, about the CCNA certification, the way you get your certification, that type of thing. Now, some of you are just in this class because you have to have a networking class, or maybe even you're doing the networking track at BCTC. You do not have to get your CCNA. You get credit for the classes that counts towards your graduation. But if you are looking for a networking job, it's probably in your best interest to, once you complete all the Cisco classes at BCTC, to go take your CCNA certification exam so that when you have a job interview, you can say, yes, I have my CCNA certificate. As far as networking jobs, there are a lot of different jobs you can get. You can design networks, you can be a system administrator, all types of jobs like that if you are knowledgeable in networking. Here they mention some IT search jobs like Monster and Indeed are probably the two most common on there. And it tells you what to search for, which are different types of jobs. I want an IT job. I want to be a network administrator. I want to be a network architect. That is somebody that designs it. Or I want to be a systems administrator. Because even if you're a computer system administrator, the more you know about networking, the better. Here we have Lab 193, which I will assign, so watch for that up here in Blackboard. And it just basically has you do a little research on what type of IT and networking jobs might be out there, what their salaries are, what's the requirements for the position, etc. 1.10 is basically finishing up the chapter. This one, what did I learn in this module, is a maybe not so brief summary of the major topics you talked about. I'm not going to read this to you. You can go back and read that and make sure you understand all the things that are listed here. And then finally, 110.2 is a module quiz. So it's longer than the Check Your Understanding. It's 15 questions over the whole chapter to make sure that you absorb the knowledge from this chapter, either from my lectures and or from reading the curriculum yourself. The very, very, very important thing, and every now and then I have students that get confused about this. This is not the part of your grade that is used to calculate your final grade in the class. That composes of, it used to be called chapter exams. Now they're called module group exams. But for example, after we complete module 1, 2, and 3, you'll take one of these module group exams over those 3 modules. That is the grade that gets averaged into your final grade. I'm not saying this is not important. Years ago, the quiz was nothing like the module group exams, and it didn't have a lot of value, but looking over these for a few of the modules that I've looked at closely, they seem to be useful. So just keep that in mind. You can do this on your own, but is not the big chunk of your grade that we talked about when we went over the syllabus. So that finishes up Module 1. Like I said, there's a couple of assignments that'll hit Blackboard in the near future related to this. And then I will start on the video for Module 2.